Hello, welcome to my channel. In this video, I'll be talking about separation techniques, which is a topic in JAMB UTME syllabus. Before I delve into the topic of separation techniques itself, I'll first of all talk about some fundamentals in chemistry, which you're supposed to know. I'll start with matter. What is matter? Matter is anything that has mass and occupies space. I believe this definition is not strange to you. And matter can exist in three states. It can exist as solid, as liquid, or as gas. The unique difference between these three states is that solid usually has its definite shape and volume, while liquid usually take the shape of the top container and it has volume, while gas does not have shape, it has neither the shape nor the volume. It usually take the shape and the volume of the container. Take note, liquid take the shape of the container, but it has its volume, while gas has neither the shape nor the volume. It usually take the shapes and the volume of the container in which it is contained. The different states of matter are interconvertible. What do I mean? A solid can change into liquid, and this happens through a process called melting. Liquid can change into gas. This happens through a process called evaporation. And gas can change into solid through condensation. The reverse can also be the case, in which solid directly change to gas. This is called sublimation, and gas can turn into liquid. This is also condensation, as in the case of gas turning into solid. Okay, and also liquid can turn into solid through freezing. Okay, so you need to take note of this interconvertibility of all the three states of matters. Every matter has its physical properties. And what do we mean by physical properties? Physical properties of every matter or substance are the properties that can be uh, assessed by our senses. Okay, the color, which you can see by the eye, the odor, which you can feel by the nose, and also the taste. Okay, other physical characteristics can be measured using instruments. One of these is the melting point, boiling point, and the density and the hardness, and also the ability of a solid, the ability of the substance to dissolve inside water. Okay, that's the solubility. All these are physical properties of matters. It's very important to note this because it has relevance in the topic that we later discuss, which is separation techniques. Chemical properties describe the substance ability to undergo changes either by itself or in combination with other substance. And usually, chemical properties has to do with changes that transform into a different that transform a substance into a different substance. And one of the chemical properties that we talk about for every matter is the reactivity with acid, base, the flammability, the oxidation states, and also the ability to rust. All these are chemical properties. Matter can also undergo physical changes. And usually, physical changes do not involve the formation of new substances, Physical changes can make matter to change from one state to another, like I've described earlier, like the melting of the ice, dissolving sugar in water. All these are physical changes. What you should note about it is there's usually no formation of new substance. When you melt an ice, it turns back to water from where it is from, right? And when you use some separation techniques, you can get back your sugar from water, right? So the water has not changed to another thing, and the sugar has also not changed to another thing. This is physical changes. Unlike in chemical changes, when it occurs, there's usually formation of one or more new substances, and it usually accompanied by energy changes, which can be in form of energy loss or energy gain. As we go ahead in other topics, you will understand this more. And an example is when you burn wood, heat is usually lost, right? So this heat that is lost is a tremendous amount of energy changes that usually accompany chemical changes. And you know when you burn a wood, it turns into charcoal. Can you get back the wood from charcoal? Not likely. So this is an example of chemical change, right? So there is formation of new substance. The rusting of iron is another example. When iron is left in the presence of oxygen and water, it can rust. And when it rusts, it forms another thing, right? It forms um, iron oxides. Okay, and from this you cannot retrieve back the iron. So there is usually formation of new substances, and energy gain or loss is involved in chemical changes. Now, the next thing we'll talk about is element. What is element? Element is pure substance and is usually made up of only one type of particle called atom. What is atom itself? Atom is the smallest indivisible particle of an element that can take part in chemical reactions. Okay? More than 100 elements has been described in nature, and elements in chemistry is usually represented with letters. And this letter can be their first letter, like in the case of hydrogen and oxygen, and it can also be a name derived from their Greek or Latin name. For example, gold is aurum in Latin, and this AU that represents gold come from aurum. Okay, I've talked about atom, which is the smallest unit of elements. Okay, and it's what take part in the chemical reaction when elements is involved. Okay, and usually atom has its specific structure. Atom has nucleus, and inside the nucleus there is proton and neutron, and around this nucleus revolve the electron. You remember the way the earth revolve around the sun? So if you remember your geography, the sun is the nucleus. As sun is to the solar system, so also the nucleus is to atom. And as earth is to the solar system revolving around the sun, so also electron is to the atom revolving around the nucleus. And don't forget, like I said, nucleus contain neutron, which is neutrally charged, and proton, which is positively charged. Okay. The next thing we'll talk about is compound. Compound is formed when two elements react together. When two or more elements react together in fixed ratio, they form compound. And like I said earlier, when elements react, what actually interacts is their atom. Okay. So elements two or more elements, when they react together, they form compound. Okay? And compounds are characterized by the fact that they are different. Their physical and chemical property are usually different from the element from which they are formed. And this is one of the major difference between compound and mixture, which we will talk about later. So example of compound is water, carbon dioxide, carbon dioxide, and sodium chloride. Mixture, on the other hand, is physical combination of two or more substances, and they usually retain their individual properties. Mixture can be homogeneous or heterogeneous. Homogeneous mixture are usually uniform in composition. When you dissolve salt in water, they form homogeneous mixture because you'll not be able to see the salt in water. It just what you'll be seeing is water, right? While heterogeneous mixture, when you mix them together, they are not uniform. You can still see the different components that make up the mixture. Like when sand is mixed with iron filament, and also when oil is mixed with water. Matter or substance can exist in pure forms, and pure substance are usually composed of only one type of particles. It can be atoms or molecule, okay? And they have fixed physical and chemical properties. Example of pure substances is gold, oxygen, which are both elements, and water and sodium, which are compounds. Meaning that pure substances can be elements or compound. What is unique about them is that they are only made up of one type of particle, either atoms or molecule. Okay? While impure substances contain two or more types of particles mixed together physically and not chemically. They do not have fixed physical or chemical properties. Okay? And an example of mixture is air and salt water, right? Now, pure substances boil at specific temperature under standard pressure. While mixture, the boiling point in mixture usually varies, and that is due to the presence of the impurities in them. These things we are talking about, we need to understand it because that's the principle that is used in separation of uh, that is what is used in the separation of in the separation techniques. Okay? A pure substance melts at a sharp fixed temperature, while impurities lower the melting point and broaden the melting range. It's also important to note that impurities, take note that it lower the melting point, but it increases the boiling point of substance. For example, if water contains impurities, it boils at higher temperature than 100 degrees Celsius. Having gone through all these basics, we'll now go into separation processes. Mixtures can be separated into their different components through uh, separation processes or separation techniques, and we'll be talking about each of them now. The first one we'll talk about is evaporation. Evaporation is usually used to separate soluble solid from a liquid, and it's usually characterized by turning the water into vapor when it is heated. When it is heated, for example, when the seawater is heated, the water leaves the container, and what is left behind is the salt. Okay, so you can get the salt back through evaporation. The next one is the simple distillation. Distillation involves when you heat a mixture and water evaporates, you can actually get that water back into a container, and this water is gotten back through this process is called distillation, and this is used in purification of water. Fractional distillation is used when liquids of different boiling points is mixed together, and it is usually used on industrial scale in crude oil refining. Okay, this is very important. You can get this in exam. The process by which crude oil is refined into its different components, including petrol, diesel, kerosene, and the rest, is through fractional distillation. And it's a process in which the crude oil is heated in a chamber that contain container at different level. So when crude oil is heated from below, heat is applied. The different liquid usually evaporate. When they evaporate, they are condensed. Okay? As you go up the chamber, the heat reduces. So the most volatile is usually at the upper chamber, while the less volatile one are usually in the lower chamber. Sublimation is a process by which solid is converted directly into gas, like I've said earlier, and this is a separation technique that is used in solids that exhibit this property, like ammonium chloride. When it is mixed with sand and you heat it, the ammonium chloride will sublime, and when it's sublime, you can get it back. Okay, this is sublimation method. Filtration is used to separate a soluble solid from a liquid. You can use it to separate garri from water. Okay, something that doesn't dissolve in water. So you can use filtration method. Okay, crystallization, usually it uses the different solubility of a solute in a solution. For example, when you dissolve salt inside water and you cool the water, you can get back the salt. Okay, because at lower temperature the solubility of salt reduces. Principal chromatography is another technique that is used in separating mixtures, and it involves the use of the mobile and the stationary phase. The stationary phase is usually the paper, and the mobile phase is usually the solvent that is used to carry the different components of the mixture. It's majorly used in separating colors. Okay. Chromatography. Column chromatography is another type of chromatography, and this is used in purification of natural products. Magnetization is used when magnetic substance is mixed with non-magnetic substance. Okay, when magnetic field is applied, the magnetic substance can be gotten back. Okay, decantation is another separation technique, and it involves uh, separation of immiscible liquids or solid liquid mixture. It allows the denser component to settle and pouring off the upper water. The 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 it pour off the upper layer, and this can be used when you want to separate when petrol mixed with water. Usually, one of them settle on the ground, and the other one will be at the top. Usually, the petrol will be on the top. Okay, or water. So you can decant this to get the supernatant. Okay. Now, having talked about the different separation technique, we'll go through some questions to test our understanding of this topic. Okay. Question number one: what characteristics of pure substance makes them suitable for calibration of thermometer? We talk about pure substance as having a fixed boiling point, and if you remember, thermometer is usually used to check the temperature of the substance. So when we have a fixed uh, temperature. When we can check the when the temperature of a substance is fixed, we can note at a particular time what the temperature is, unlike in case of impure substances where the temperature is usually a range. So let's go through the option. What characteristic of pure substances makes them suitable for calibration of thermometer? They have a uniform density. This is not correct. They have a sharp and fixed melting and boiling point. This is probably correct. They can be easily separated into components. No. Pure substances cannot be separated into components. They dissolve readily in water. This is not the property that make them suitable. Because when you talk of thermometer, we want to know the melting and boiling points. So therefore, B is the correct answer. Next question. Why is seawater classified as a mixture rather than a compound? A is chemically bonded. It is not correct. Its components are present in a fixed ratio. This is not correct. Its components can be separated by physical means. This is correct. It has a sharp boiling point. Let me quickly talk about, for those of us that may probably have not have the experience of what seawater is. Seawater usually contain salt. It's usually salty. If you have been close to the sea before and you taste the water, it usually contains salt. So it's impure. It's an impure, so it's an impure water. And earlier we said when we were talking about the physical properties of impure substances, they usually they can be separated by physical means. Okay, they do not usually have sharp boiling point. They usually boil at if at a range of temperature. So this cannot be correct. Question number three. A sample of water is found to boil at 120 degrees Celsius. What can be inferred about its purity? We know pure water boil at 100 degrees Celsius. So it means it's a pure substance. Is not correct. It's contaminated with solute. Is true. Its boiling points, it is boiling under reduced pressure. This is not correct because if water boil under reduced pressure, the boiling point is usually lower. Okay. The water molecules have decomposed. No, this is not correct. So the answer is B. Next question. Why does fractional distillation require a fractionating column? To cool the mixture rapidly is not correct. To increase the surface area for condensation and vaporization is correct. To separate immiscible liquids, to separate immiscible liquids, this is not correct because if you want to separate immiscible liquids, you rather use decantation method. Okay, to reduce the boiling point of the mixture, this is not correct. It usually have fractionating column so that the different components can evaporate and turn into vapor, and there will be surface area for them to condense. Okay, so the correct answer is B. How does chromatography separate components in a mixture? By their density? That's not correct because chromatography have a stationary medium and a mobile medium. The mobile medium is usually a solvent, which can be water. The stationary medium is usually, in case of paper chromatography, is usually a paper. So when you put a dot of ink here and you dip the water, you dip the paper slightly into water such that water rise through capillary action. The water is now the uh, mobile phase and it separates it into the difference component. So the properties is used is actually the solubility in water and the adherence to the paper, which happen to be the stationary medium. Okay, so it's not the density. B, by their solubility and interaction with the stationary medium, stationary and mobile phase is correct. By their magnetic properties, this is not correct because this is used in magnetization. By the ability to form crystals, this is not correct. This is used in crystallization. Okay. Next question. A mixture of iodine and sand is heated. Iodine transition directly from solid to gas. What separation technique is used here? Crystallization, no. In crystallization, usually when solution is cooled, the solutes usually crystallize out. Okay. Sublimation, yes. Sublimation because solid turn directly into gas. Okay, that's sublimation method, which is correct. Evaporation is usually when water turn into vapor. Okay, this is not correct. And decantation is this is not correct. Okay, as this is used to separate immiscible liquids or a solid, a liquid contain insoluble solid. Okay, so the answer here too is B. If a sample of ink is placed on chromatographic paper and separated into several bands, what does each band represent? A component with a different boiling point. That is not correct. In the last question, we talk about their solubility and their interaction, the solubility in the mobile phase and their interaction with the stationary phase. Okay, so it's not about boiling points. Component with a unique solubility in the solvent, a component that is insoluble in water, a component with magnetic properties. This is the correct answer. B. What distinguishes compounds from mixture? I'll leave the remaining question for you to attempt, try and go through them, and comment in the section below whatever you think is the answer. We can open up discussion in the comment section and we can learn more when we interact in it. So, like this video, subscribe, and share for others to benefit. As you are going through this question, you can take a pause so that you will be able to read the question and answer it. Like, subscribe, and share, and comment your answer in the section below. I wish you the best. Bye bye.